So quiz tomorrow is on 2.1 through 2.3. Let's start by looking at the quadratic stuff. So some 2.1. We want to find the vertex, the x and y intercepts, the axis of symmetry, max and min, and write the standard form, which is vertex form, and then sketch the graph. So lots to do with this one question. First thing I'm going to do is let's just rearrange this and put it into what we call standard form. So I'm just going to start with the highest degree. We have negative x squared minus 2x plus 8. Just have that x squared be first. Next thing we want to do is find the vertex. What's the little formula that we use to find the vertex? Negative b over 2a. That helps us find the x value in our vertex. So when we do negative b over 2a, our a is negative 1, our b is negative 2, and c is 8. So negative 2 over 2 times negative 1. So this turns to positive 2 over negative 2, which would simplify to negative 1. How do we find the y in our vertex? Plug it in. So we're going to plug in the x to find our y. So this is our x in our vertex, negative 1. I'm going to plug it into the x's in my original function. So we have negative 1 squared minus 2 times negative 1 plus 8. Be careful with the order of operations here. You have to square the negative 1 first before you multiply by the negative on the outside. So negative 1 squared would be positive 1. Positive 1 times negative 1 would be negative 1. Plus 2 plus 8. So this would be 1 plus 8, which would be 9. So the y value in our vertex is 9. So first thing we found was our vertex, which is negative 1, 9. That tells us what our axis of symmetry is. What is our axis of symmetry? X equals negative 1. It's always the x value from your vertex. We can also put this into vertex form. Our vertex form is y equals a times x minus h squared plus k, where our h and k come from our vertex. So we have y equals, what's our a? A was negative 1, same as the a in our original function here. A is negative 1. So we have negative 1, or just negative, times x minus h. So how would I write x minus negative 1? X plus 1 squared, don't forget the little squared, plus k, which is 9. So that would be our vertex form. One other thing that we can find right off the bat is our domain. What would our domain be here? What's our domain always for quadratic functions? Negative infinity to positive infinity. It is always going to be all real numbers for your domain. Now let's think about the graph of our function here. So I'm going to just kind of lightly graph it. I'm going to go to the left 1 and up 9. Is our graph going to open up or open down? How do we know that it opens down? Because a is negative. Our leading coefficient's negative, so we know that it's going to open down. So looking at our graph here, what do you think our range would be? Awesome. Negative infinity to 9. Since it goes down, it's going down to negative infinity. So negative infinity to whatever our y value is in our vertex, our k, which is 9. And it's always going to be a closed circle there, so it's a bracket at the 9. Now going back to our graph, is our vertex at the maximum or minimum? It's at the maximum. It's at the highest point. So we would say that this has a maximum at what number? 9. Your max and min is always the k value from your vertex. So our max is at 9. So to find everything that we just found, we have to start by finding the vertex. Once we find the vertex, the axis of symmetry is going to be the h from your vertex. The range and the max or min is going to repeat the y from your vertex, or the k. And then vertex form, you need the vertex in order to do that. Last thing, let's find the x and the y-intercept. How would we find the x-intercept? What do we do? Plug in 0 for y. So we make y 0. So I have 0 equals negative x squared minus 2x plus 8. Now we want to solve for x. How would we solve for x in something like this? We can do the first time's the last to factor. I don't really love when our leading coefficient's negative, so what I'm going to do is take out a GCF of -1. I'm going to divide everything by -1, just to make our factoring a little bit easier for us. So we have 0 equals x squared plus 2x minus 8. From here we can factor normally. What are two factors of -8 that add to 2? 4 and -2, awesome. So we have x plus 4 and x minus 2. So what would x equal? -4 and 2. So these are our x-intercepts. We would want to write them as points. So since it's what x is equal to, they go in the x spot. So -4, 0 and 2, 0. Now let's do the same thing and find the y-intercepts. What do you think we do to find the y-intercepts? Plug in 0 for x. So I have f of x, or I'm just going to call it y, equals -1 times 0 squared minus 2 times 0 plus 8. So what would y equal? 8, awesome. This is 0, so y is equal to 8. So again, we want to write that as a point. Since it's what y is equal to, it's going to go in the y spot. So we have 0, 8 for our point for the y-intercept. So x and the y-intercepts need to be coordinate points. You got to write it as an ordered pair. All right, I'm just going to do one of each type of question, but before I move on, just looking at number 2, what's the first thing I should do here? Rearrange it. Put it into standard form. We have 3x squared minus x plus 2. So always want to rearrange it. Put your highest degree first. All right, number 3 is super similar. So again, you want to find the coordinates of the vertex. So you're going to do your -b over 2a to find the x value in your vertex. Plug it in to find the y value. And then this question also asks if we have a maximum or minimum. Which direction is our graph going to open here? It opens up. So our vertex is going to be at the max or the min? It'll be at the minimum. And the minimum is going to be whatever our y value is, or the k in our vertex. So I'll put k/y, whatever. I'll just leave it as k. But the minimum's at k in the vertex. So you got to find your k from your vertex. That's your minimum value. All right, so let's look at number 2. First thing, what's our domain going to be? -infinity to +infinity. That should be like a gimme question for you guys. Next, let's find our vertex. How do we find the vertex? -b over 2a. So our a is -3, our b is -1, and c is 2. So starting with the x from our vertex, we have -1 over 2 times -3. So this would be 1 over -6. So for our vertex, the x value is going to be -1 over 6. How do we find the y value? Plug it in. So we're going to plug in the x to find the y. So in my x's, I'm going to plug in negative 1 over 6. So negative 3 times negative 1 over 6 squared minus 1 over negative 6 plus 2. Be careful with the math here. Make sure you follow your order of operations. Negative 1 over 6, we have to square it first, so it would be 1 over 36. This turns into plus 1 over 6 plus 2. Next, I have to multiply. So before you can add, you got to multiply. So 3 over 36. You can simplify it, or just leave it as negative 3 over 36 and simplify at the end. Doesn't matter how you want to do it. I'll simplify it now. So negative 3 over 36 would be negative 1 over 12. Plus 1 over 6 plus 2. We need a common denominator to add fractions. So I'm going to multiply the top and the bottom here by 2. So we get 2 over 12. And while I'm at it, I'm going to multiply the top and the bottom of 2 over 1 by 12 to give us a common denominator here. So this would be 24 over 12. So we're going to add all of our numerators together. We get 25 over 12. So that would be our y value, 25 over 12. So our vertex is going to be negative 1 over 6, comma, 25 over 12. We can put it into vertex form. So y equals a times x minus h squared plus k. So y equals, what's our a? Negative 3, perfect. Negative 3 times x minus h. This is our h and our k. So minus negative 1 over 6 would be plus 1 over 6 squared plus k, so plus 25 over 12. What's our axis of symmetry? X equals negative 1 over 6. Perfect. It's always your x in your vertex. So x equals, axis of symmetry is going to be a line. So don't forget that x equals. Then we can also find the max and min in our range, but we need to know in what direction is this going to open. So for our graph, I'd go to the left to negative 1 over 6 and up 25 over 12. Does it open up or down? Our graph opens down. How do we know? A is negative. So we know that it's going to open down. So for our range, what will our range be? Awesome. Negative infinity to 25 over 12 with a bracket. So it's always the same y value from your vertex. Is our vertex at the maximum or minimum? It's at the maximum. It's at the highest point. So our maximum value is at what? 25 over 12. Again, it is your k from your vertex. So your k repeats in the range, the vertex, and the max or min. So last thing we need to do is find the x and the y-intercept. Let's start with the x-intercept. How do we find the x-intercept? Make y 0. So we're going to plug in 0 for y. 0 equals negative 3x squared minus x plus 2. I don't love factoring when our leading coefficient's negative, so I'm going to divide everything by negative 1. You definitely can factor when your leading coefficient's negative. Just be careful with the signs when you do it. I would always recommend checking at the end just by foiling a little bit to see if you factored correctly, especially when your leading coefficient's negative. So I'm just going to divide everything by negative 1. Let's get rid of that negative. So 0 equals 3x squared plus x minus 2. How would we factor this? Awesome. Multiply the first times the last. We get -6. What are two factors of -6 that add to 1? 3 and -2. So we have x plus 3 and x minus 2. What do we have to remember to do next? Divide by 3. If you start by multiplying, don't forget to divide. So we get x plus 1 and 3x minus 2. So we simplified where we could. If it doesn't simplify, move it in front of the x. So what would x equal? -1 and +2/3. So when you write that as your x-intercept, make sure you write it as coordinate points. So -1, 0 and 2/3, 0. How do we find the y-intercept? Plug in 0 for x. So we have y equals -3 times 0 squared minus 0 plus 2. What would y equal? 2. Awesome. So we want to write that as a point. What would our point be? 0, 2. The number is going to go in the y spot. All right. So looking at number 4, it says use the leading coefficient test to determine the end behavior of the polynomial. Find the number of turns, the x-intercepts, the multiplicity, and the y-intercepts, and graph. So let's find everything here. First thing I want to do is put this into standard form. I'm going to put my leading term first. So 2x cubed plus 3x. Now we can start by finding our end behavior. Looking at our highest degree, is our exponent even or odd? Exponent is odd. So are they going to go in the same direction or opposite directions? Opposite. And if our leading coefficient's positive, what's our left arrow going to do? Left arrow goes down, and the right arrow is going to go in the opposite direction, so up. So for my end behavior, I would say falls left and rises right. If you want to draw the arrows that go with it, you can, but I'm also looking for the word, so make sure you say if it falls or it rises and which one. So falls left and rises right. Let's find our zeros next. What would we do to find the zeros? Equal it to 0. And then what? Let's take out the GCF. Our GCF would be x. So we have 2x squared plus 3. Once we factor it all the way, what could we do next? Set each piece equal to 0. So here we have x equals 0 and 2x squared plus 3 equals 0. So x equals 0 is already solved for us. Let's solve the other one. We're going to subtract 3 on both sides. So 2x squared equals -3. Divide by 2. So x squared equals -3 halves. Then what do we do? Square root. What do we get? An imaginary number. So this one does not give us a solution. It's not that our whole question is no solution because I still had x equals 0. But this one doesn't give us another 0. So for my zeros, I have x equals 0. Let's talk about multiplicity. How many x equals 0s do we have? 1. So I have a multiplicity of 1 at x equals 0. And when we have a multiplicity of 1, what's our action at the x-axis? It crosses. Awesome. It's either going to cross or touch and turn, or bounce if you want to call it. When it's odd, it crosses. When it's even, it touches and turns. But here, since our multiplicity is odd, we cross at the x-axis. This graph is going to look a little bit funky just because we do have imaginary zeros. So if we were to graph this, we've got a point at 0. Our end behavior falls to the left and rises to the right. So it almost looks linear. It kind of does something like a little funky like this up here, where like the other value doesn't touch the x-axis. But we're not looking for anything super exact. I'm looking for the zeros, your end behavior, and the action at the x-axis. Does it cross or does it touch and turn? This one's kind of hard to graph, so we wouldn't ask you something like this, but it'd probably have more zeros so we can see a better graph. No, if we had a graph, like let's say we had x equals 1 and x equals 1, where we had even multiplicity. So at x equals 1, I mean, it depends on which direction you're coming from, but our graph would kind of look like this, where it just touches and turns. No. I mean, it would be the same, like if I had a point here and a point here, and our end behavior looked like this. And let's say we cross the x-axis at the first one, we touch and turn at the next, and then touch and turn at the next. It would just look like that. So you just kind of got to follow your points, make sure you know your action at the x-axis, and know that you can only ever touch the x-axis at your zeros. So you're not going to like cross here, cross here, cross here to get to the next point because we touch here. So you're only ever going to touch the x-axis at your zeros. So for number 5, we want to find our end behavior, the zeros, the multiplicity, and the action at the x-axis. So we could start by finding the end behavior. So looking at our highest degree term, is it even or odd? Even. So do they go in the same direction or opposite directions? And then if it's a positive leading coefficient, are they both going to go up or down? Both go up. So in words, I would say that it rises left and right. So rises left and rises right. Next, let's find our zeros. So if we have 4 terms, how could we try to factor this? Grouping. Let's group our first 2 and group the second 2. What's the GCF from our first group? X cubed. When we take out an x cubed, we're left with x minus 6. What's the GCF from our second group? Negative 2x. Perfect. When we take out a negative 2x, what are we left with? X minus 6. So we're going to put our 2 outsides together. So x cubed minus 2x. And then we have an x minus 6. Now looking at our answer here, I probably should have done this in the beginning, but can I factor this anymore? I have a GCF from this group here. What's our GCF? X. So I'm going to take out that x. So we have x times x squared minus 2 times x minus 6. So in the beginning, I see that all of my terms had an x. I should have taken out the GCF of an x at the start, but you can do it at the end too. So this is as factored as we can go. What do we do next to find the zeros? Set them all equal to 0. So we have x equals 0, x squared minus 2 equals 0, and x minus 6 equals 0. So x equals 0 is already solved for us. That's going to be one of our answers. Second one, we have x equals, or I guess the third one, x equals 6. Let's look at the middle one here. I'm going to add 2 to both sides. So x squared equals 2. What should we do next? Square root both sides. So what does x equal? Plus or minus square root 2. So this gives us our 4 answers here. We knew we were going to have 4 from the start because it was an x to the 4th power graph. So our zeros are going to be 0, negative square root 2, positive square root 2, and 6. Do we have any multiplicity? No. You could either say no multiplicity or multiplicity of 1. Because we just have 1 of each answer. So at every single value here, we just have a multiplicity of 1. Now when our multiplicity is odd, what's our action at the x-axis? It's going to go through or it's going to cross. Either way is fine. Through or cross, whatever you want to call it. Remember, if your multiplicity is even, so if even multiplicity, then it touches and turns or bounces off the x-axis. But let's graph this now. So I'm going to start by putting my zeros on my graph. I have a point at 0, a point at negative square root 2, which is just going to be a little bit more than 1, or negative 1, I guess, a little bit less than negative 1. In between negative 2 and negative 1. Square root 2 is going to be in between 1 and 2, and then 6. 1, 2, 3, 4, 5, 6. Now our end behavior, we said it rises to the left and rises to the right. So out of my point farthest to the left, I'm going to have an arrow that goes up. And out of my point farthest to the right, I have an arrow that goes up. And then what do we do at each point here? We're going to cross the x-axis. So I cross the x-axis at this point, go to the next one, cross the x-axis, cross the x-axis, and cross the x-axis.
Are you going to make this graphic?
Yes. You'll have to graph, but with your graph, I'm just looking for you putting the zeros, you're putting the end behavior on it, and you're either crossing it or touching and turning. So it doesn't have to be perfect. It doesn't have to be super pretty, but I need to see all of these things on your graph. I got to see the zeros, I got to see the end behavior, and I have to see the action at the x-axis. Remember, you're only ever going to touch the x-axis at your zeros. So if you end up doing something odd like this, where you touch it in other spots, it's going to be wrong. So you can only ever touch the x-axis at your zeros. We'll practice a long division one. Let's look at 8. So for our long division, outside the box, we have negative 4x minus 3. Inside, got 8x to the third power plus 18x squared plus 13x plus 5. So for long division, the first step we always want to do is divide. We're going to divide the first term by the first term. So what is 8x to the third power divided by negative 4x? Negative 2x squared. So I'm going to put that on top of my x squared term, negative 2x squared. Next, we want to multiply what we wrote up top with both things out front. So we get 8x to the third power plus 6x squared. Then in this step, right after we multiply, we change the signs of both of these things and combine. So the 8x cubes will cancel. Your first ones are always going to cancel out. 18x squared minus 6x squared would be 12x squared. Then we do the same thing again. We're going to divide 12x squared by negative 4x. What's 12x squared divided by negative 4x? Negative 3x. Then we multiply negative 3x times everything out front. So we get 12x squared plus 9x. Then we change the sign, and combine. The first ones are always going to cancel. They're always going to be opposite signs, so they'll cancel. We can drop down the 13x. So 13x minus 9x would be 4x. And we do it again. What's 4x divided by negative 4x? Negative 1. Perfect. Then we multiply negative 1 times everything out front. So we get 4x plus 3. Change the sign, and combine. The 4x's cancel. I'm going to drop down the 5 to combine these. 5 minus 3 would be 2. I already wrote my constant though, so what is 2? The remainder. So we have a remainder of 2. So this would be our answer. You don't have to write it as a fraction like web assign. If you want to just leave it as remainder 2, that's perfectly fine on the quiz. Yeah. Be super, super careful with these types of questions. It's a lot of little math going on. You need to be careful with your signs. One negative sign or one opposite sign in the beginning will throw off the rest of your answer. So just be very careful with your work for these types of questions. Let's do number 10. It says divide using synthetic division to determine if x plus 2 is a factor of the polynomial. So for number 10, what's going to go outside of our box? Negative 2. X would equal negative 2. Inside the box, we want to put all of our coefficients. Let's make sure we're not missing anything. I have x to the 5th power, 4th power, 3rd power, 2nd power, 1st power, and our constant. So we're good to go. So in my box, I'm going to put my coefficients 1, negative 3, negative 7, 1, negative 1, and 18. Just like we did for long division, be super careful with your signs here. Be super careful with the little math. I'm going to drop down the first number, multiply on the outside. We get negative 2, add on the inside, negative 5. Multiply, this would be positive 10. Add, we get 3. Multiply, negative 6. Add, negative 5. Multiply, 10. Add, this would be 9. Multiply, negative 18. Add, we get 0. Is x plus 2 a factor? Yes. So that's what this question is asking, is to determine if x plus 2 is a factor. So yes, it's a factor. When you get 0 as the remainder, it is a factor. For number 12, use synthetic division and the remainder theorem to find the indicated function value. If it says to use the remainder theorem, what does that tell us that our answer is going to be? When we use synthetic division, what's our answer going to be here? The remainder. It says use the remainder theorem to evaluate, or use the remainder theorem to find the indicated function value, to find the value. The remainder is our answer. What's going to go outside the box here? Negative 3. Here it says f of negative 3. This is the same thing as saying x equals negative 3. So exactly what it says is going to go outside the box. Inside the box, let's make sure we're not missing any terms. We have the 3rd power, 2nd power, 1st power constant, so we are good to go. We're not missing anything, so we're just going to put our coefficients in the box. 4, negative 8, negative 4, and 23. So first thing we want to do is drop down the 4, multiply on the outside, we get negative 12. Add on the inside, negative 20. Multiply, we get 60. Add, this would be 56. Multiply, I'm going to do it on the side over here. 56 times 3 would be 168. 15, 16. Okay, yeah. So 168, negative 168. And negative 168 plus 23 would be negative 145. So what is our answer here? Negative 145, just the remainder. So f of negative 3 is negative 145. So let's practice a long division one with number 9. Outside the box, we have 3x minus 4. Inside, make sure you're not missing any terms. Here I've got 12x cubed, x squared, x, and a constant. So we're not missing anything, so we can put those in the box. 12x cubed minus 10x squared minus 17x plus 12. So with long division, first thing we want to do is divide. What's 12x cubed divided by 3x? 4x squared, and I'm going to put that on top of my x squared term. After we divide, we multiply. We're going to multiply what we wrote up top with everything out front. So 4x squared times 3x would be 12x cubed. And 4x squared times negative 4 is negative 16x squared. Next step, in what we just multiplied, you have to change the signs. So change the signs of both of them and combine. So the first ones are always going to cancel. Negative 10x squared plus 16x squared is 6x squared. Then we do it again. We're going to divide. So back to the top. 6x squared divided by 3x would be what? 2x. And I'm going to write that on top of my x term. I'm going to keep all my like terms in line. I'm going to multiply 2x by everything out front. So we get 6x squared minus 8x. Change the signs and combine. 6x squareds cancel. I'm going to drop down negative 17x. Negative 17x plus 8x would be negative 9x. Then we divide again. Negative 9x divided by 3x. Negative 3. Then we multiply. Negative 3 times 3x is negative 9x. Negative 3 times 4 would be 12. Yeah, positive 12. Change the signs and combine. So the 9x's cancel. I'm going to drop down this 12. 12 minus 12 is 0. So here we have no remainder. Our answer is just what we wrote up top. So 4x squared plus 2x minus 3. If you did have a remainder, you can leave it on the quiz as remainder, whatever your number is. Just, you could put the R. You don't have to write the fraction. So in number 8, we had a remainder. You can just leave it as remainder 2. So with 11, we are dividing using synthetic division to determine if it's a polynomial. So what's going to go outside the box here? 6. Awesome. X would equal 6. We change the sign. Inside the box, we have to be careful. We're missing quite a few terms here. I'm missing an x to the third power, x to the second power, and an x. So I have to make sure I include 0x to the third power, 0x squared, and 0x. So inside the box, we have 1, 0, 0, 0, and 1,296. So I'm going to drop down the 1, multiply on the outside, we get 6, add 6, multiply 36, add 36, multiply, we get 216, add 216, multiply 1,296, add 2,592. Is x minus 6 a factor? No, not a factor. What would it take to be a factor? We would need the remainder to be 0. The remainder has to be 0 in order for it to be a factor. Here, remainder is not 0. But let's write out our answer. If I started with x to the fourth power, what's our answer going to start with? X to the third power, 1 less. We have x to the third power plus 6x squared plus 36x plus 216, remainder 2,592. You guys don't get a calculator on the quiz, but I promise the numbers won't be this large. But remember, you could always just write it down to multiply. If you had 216 times 6, just multiply it out. 6 times 6 is 36. 6 times 1 is 6, plus 3 is 9. 6 times 2 is 12, so 1,296. So you could always just write it out and multiply. All right, let's look at 13. 13 says to solve the equation, given that 1 is a root. Saying that 1 is a root is the same thing as saying 1 is a 0, 1 is a solution. Root, solution, 0 all mean the same thing. So what would I do first here? What could I do to find my other x's? If you want to try grouping, you can. Grouping's not going to work here, though. Remember, when you group, you need the insides to be exactly the same. If it doesn't work, you can't group. We're going to use synthetic division and put 1 on the outside. So we want to divide, make this a little bit smaller, so then hopefully we can factor. Inside the box, I'm not missing any terms, so I have 12, negative 25, 16, and negative 3. So I'm going to drop down the 12, multiply, we get 12. Add negative 13, multiply negative 13, add 3, multiply 3, add 0. So is 1 a root? Is 1 a 0? Yes. We knew that from the beginning, but it helps to find it. Now that we made our polynomial smaller, let's see if we can factor this. Since we started with x to the third power, what's our answer going to start with? X squared minus 13x plus 3. So once you break it down to an x squared, try to factor. We have 12x squared minus 13x plus 3. What would we do to factor here? Awesome. Multiply the first times the last. I still didn't give myself enough room here, but we'll make it work. 12 times 3 is 36. What are two factors of 36 that add to negative 13? Awesome. Negative 9 and negative 4. So this is going to factor into x minus 9 and x minus 4. But when we factor this way, what do we have to remember to do? Divide by 12. So both of our numbers need to get divided by 12. Simplify the fraction if you can. How could I simplify 9 over 12? We can divide them both by 3, so we're left with 3 over 4. What do we do with the denominator if it still doesn't simplify? Put it in front of the x. So this would be 4x minus 3. How can I simplify 4 over 12? Divide them both by 4. So when we divide them both by 4, we get 1 over 3. What do we do with the denominator? Move it in front of the x. So 3x minus 1. So these are our other two factors. This says to solve, so we're going to solve it all the way. What would I do to find the zeros? How do I find what x is equal to? We're going to set them both equal to 0. So when I set them equal to 0, I'm going to add 3 to move it to the other side, and then divide by 4. So x is equal to 3 over 4. Same thing here. Set it equal to 0. We're going to add 1 and divide by 3. So x is equal to 1 over 3. So here's two of our answers. What was the other answer? 1. Awesome. The one that was given to us was 1 is a root, so x also equals 1. And then in the beginning, since our highest degree was 3, we knew that we were going to have 3 answers. So these are 3 answers, or our 3 zeros, or roots. But for 14, when we use synthetic division to find our other roots or our other zeros, what would we do first? Do what? Rearrange it. We want to put it into standard form. So we have x to the third power plus 3x squared minus 4x minus 12. Super, super, super important that you rearrange it before you start doing synthetic division. The quiz will probably try to trick you like this question, and it'll make you rearrange it. People always fall for that trick. So make sure you rearrange it, put it into standard form before you start synthetic division. So for the last one here, it says find all the roots, use the rational root test. So we want to solve. How many answers am I going to have here? 4. We're going to have 4 answers. Whatever our highest degree is how many answers we'll have. Now, it's in standard form, but it doesn't give me any roots to start off with. So what would I do to find possible answers? Awesome. We want to find factors of the last over factors of the first. So last over first. This is what we did yesterday for the juniors that missed. So make sure you watch the video if you haven't. So factors of the last over factors of the first. What are factors of negative 4? So plus or minus 1 and 4. What else? and 2. So the positive and negatives of all of these, whether your last term is positive or negative, it's always the plus or minus of your answers or of the factors. What are factors of our first? Awesome. Our leading coefficient is just 1, so factors of the first would just be 1. So these are all of our possible zeros. How do we see what is actually a 0? Synthetic division. Our goal is to get 0 as the remainder to see what is actually a 0. Before you plug it into your box, make sure you're not missing any terms. I have x to the 4th power, 3rd power, 2nd power, 1st power, constant. So we're good. Let's put our coefficients. 1, 2, -3, -8, -4. What do you want to try first? Sure, we could try 1. I'm going to drop down the 1, multiply on the outside. We get 1, 3, multiply 3, add 0, multiply 0, add -8, multiply -8. Does 1 work? No. As soon as you see that it doesn't work, you can stop and move on to the next number. Remember, you got to try all of these to see what works. What should we try next? Sure, let's try -1. Multiply, we get -1, add 1, multiply -1, add -4, multiply, this would be +4, add -4, multiply +4. Does it work? Yes, it works. So one of our answers is going to be x is equal to -1. Now we have 3 more answers to find. So you could try in this step if you want to factor by grouping. You can try. Sometimes it's not going to work to factor by grouping. But if it doesn't, or if you don't even want to try to factor when you still have, this is x to the 3rd power because it's 1 less than what we started with. So if you still have more than an x squared, do your last over first again. So I'm going to do last over first again, but now I'm going to take these answers and put them in the box. So 1, 1, -4, -4. So we're going to do synthetic division again, but with the answers that we just found. What do you want to try next? Sure, we could try 4. So I'm going to drop down the 1, multiply, we get 4, add 5, multiply 20, add 16, multiply 64. Does it work? No. As soon as you see it doesn't work, you can stop and try something else. What else do you want to try? We tried 1 the first time. It didn't work, so it's not going to work again. Let's try -2. So -2, we get -1, +2, this would be -2, +4. Does it work? Yes, it works. I'm going to add it to my list, -2. Now with this answer, it's 1 degree less than the one that we just started with, so this is an x squared minus 1x minus 2. From here, we can just factor. So once you get down to an x squared, just factor it. What are 2 factors of -2 that add to -1? -2 and 1. So x minus 2 and x plus 1. So what would x equal? 2 and -1. So I'm going to add those to my list. X equals 2 and -1. So notice how -1 repeats. If we would have tried -1 the first time and the second time, it would have worked both times. So you can get an answer that repeats. You can try something that worked the first time, but if it didn't work the first time, it's not going to work the second time also. So these are our 4 answers. So you want to keep doing your last over first until you get down to x squared. Once you get down to x squared, then factor it. What do we do if something does not factor? How could we find our zeros? Quadratic formula, -b plus or minus the square root of b squared minus 4ac over 2a, if it does not factor. right, let's go back to 14. It says use synthetic division to find the roots of the polynomial given that the polynomial has x equals -3 as a root. So we know that x equals -3 is going to be one of our zeros. What goes on the outside then? So if it says x equals, we put exactly what it says. So -3 would go on the outside. Then inside the box, we're going to put our coefficients. Make sure you put your coefficients in the new order that you have, so in standard form. And we're not missing any terms, so we're good to go there. So 1, 3, -4, -12. So we're going to drop down the 1, multiply on the outside, we get -3. Add 0, multiply 0, add -4, multiply 12, add 0. Does -3 work? Yeah. We knew that it was going to work in the beginning because it told us that it was a 0. But x is equal to -3. How many more answers do we need to find? 2 more because we have 3 answers total. Once you get down to just 2 answers to find, what could we do? Factor. This is x squared plus 0x minus 4, so just x squared minus 4. How could I factor x squared minus 4? Awesome. This is the difference of squares. It factors into x plus 2, x minus 2. So what would x equal? 2 and -2. Perfect. So 2 and -2. So these would be our 3 zeros.